All right, so in section 4, we start graphing sine and cosine functions. Now, if you take a look, right, at how a sine or a cosine function looks, right? We have examples down here. What's the one word that comes to mind? What are these what are these graphs? What do they look like?
Wavelengths.
They look like waves, right? That's what sine and cosine graphs are. They're waves basically when you graph them. So these graphs, they oscillate, that's the word, they oscillate around the x-axis, and they go on forever and ever and ever on the x-axis to positive infinity and to negative infinity. Now, what do you notice here is they all have the same maximum point, right? All of these cycles have the same maximum point, and they have the same minimum point. Okay, we're going to talk a lot about this in a little while. Let's look at what the sine and cosine equations look like. So basically the general form of the equations are this. So we have a sine bx plus c plus d, and each of these a, b, c, d serve a purpose in the life of the function. Okay, you guys have seen this before, right? This is the unit circle that we've been using. Is that right? So let's familiarize ourselves with this. Here, when I have an angle of pi over 6, okay, right? If I have an angle of pi over 6 or 30 degrees, and I draw my triangle that way, do you see how the vertical side, because this is the 30-degree angle, the vertical side is 1/2 and the horizontal side is √3/2, right? That's what we always drew. Is that right? That was our basic triangle. So in this case, the cosine is √3/2 and the sine is 1/2. So on this unit circle, they've written that for us. The cosine is √3/2 and the sine is 1/2. If I were to draw the 60-degree here, or the pi over 3, now the vertical side is √3/2, the horizontal side is 1/2. So the cosine is 1/2 and the sine is √3/2. All right, so that's how this looks. So when I look at these coordinate points on the unit circle, the x value is always cosine, the y value is always sine. And we knew that, right? We knew that because when the angle is 0 degrees and I have a coordinate point of 1, 0, x is cosine, y is sine. X is cosine, y is sine. Okay, now what we're going to do is this. We're going to graph sine of theta. But check out what we're going to do. Here on the bottom, I have the x-axis and the y-axis. On the x-axis, I have my angles. 0, pi over 2, pi, 3 pi over 2, and 2 pi. They're the same angles as is on the unit circle. What we're going to do is we're going to go to each angle, and on the y-axis, or in the y, we're going to plot the sine values. Okay? So, what do I mean by that? Okay, so the sine, that's our red ones, right? Here, when x is 0, look at the unit circle. When the angle is 0, how much is the sine of it?
0.
0, right? So we're going to go from the unit circle because it's... So when the angle is 0, what's sine? 0. That's the y value, remember? How it was always cosine and sine. So look at how we're going to graph that here. When x is 0, sine is 0. When the angle is 0, sine is 0. Okay, now let me make this a little bit bigger. Okay, look at this x-axis here. Okay, if I have pi over 2, this one, how much is this? Pi over 4. And then I have pi over half a pi. And then here I have 3 pi over 4. And after the pi, I have 5 pi over 4. And then 7 pi over 4. What just happened? Oh no. Okay, at pi over 4, okay, when the angle is pi over 4, how much is sine? At pi over 4, how much is sine? Root 2 over 2, right? How much is root 2 over 2 in decimals on your calculator? 0.7071. Okay, so when the angle is pi over 4, sine is 0.7. So this is 0.5, this is 0.75, so we're somewhere there. Now, when the angle is pi over 2, how much is sine? When the angle is pi over 2, how much is sine? Look on the unit circle. 1, this one. So when the angle is pi over 2, sine is 1. When the angle is 3 pi over 4, how much is sine?
So how do you recognize, like, to go, like, why are we going to the entire unit?
Because that's what we're going to do. We're going to graph this for one cycle of the unit circle and see what it looks like.
But
Yeah.
because it says sine of theta, so how, like, what's theta?
Theta is the angle.
But I know, but how do you know what angle you're like? How did you know it was 0?
So this axis here now represents the angle theta. So here I put my like significant angles, right?
So is it basically just gonna turn into a circle?
It's not. Look at what it's going to turn into. Let's do it and you'll see what it's going to turn into. Okay, so when the angle is 3 pi over 4, sine is 0.7 again. So 3 pi over 4, sine is 7. At pi, how much is the sine?
Negative.
0, the sine. At 5 pi over 4, how much is the sine? Negative root 2 over 2, which is negative 0.7. At 3 pi over 2, how much is the sine? Negative 1. 7 pi over 4, how much is the sine? Negative root 2 over 2, which is negative 0.7. Okay, and then at 2 pi, how much is the sine?
0.
0. So let's plot this. Look at what it looks like. You see what it looks like?
Mm-hmm.
That is one cycle of the sine function. How did we get it? We got it from the same values on the unit circle that we've been working with all year long, right? Yeah.
What does it say in between, like, the 0 and the
It's the pi over 4. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. It's these pi over 4s. Pi over 4, 3 pi over 4, 5 pi over 4. I just put them on, yeah, so it's easier for us. Okay, so now a few things here. Look at all of the values that we always got here, right? We always got a value of 0, 1/2, root 2 over 2, root 3 over 2, or 1, right? So the lowest number that we always went to was negative 1. The highest number that we ever got when we did everything for the last test, The highest number we ever got was 1. So we always went from -1 to 1. You see how these values here, the lowest is -1, and then the highest is +1. It's the same thing on the graph. Once you graph it, the lowest value that your graph hits is -1, and the highest value that your graph hits is +1. Okay? That's because we're using the same values on the unit circle. And that's how we're always going to do these. So now we're going to do this. Again, let's label pi/4, 3 pi/4, 5 pi/4, 7 pi/4. Now here, we're going to graph cosine. So when my angle is 0, okay, when my angle is 0 on the unit circle, how much is the cosine? 1. So at 0, my cosine is 1. At pi/4, how much is the cosine? We're at 2/2, which is 0.71. All right? I'm going to give you guys a minute to complete the rest of this for me. All right? Going with the cosine values. Go. So did we get something like this? Right? So when you do this, remember that this is a sine or a cosine, which is a wave. So we're not going to do a V with corners. We're going to have something that looks like a wave, just like that. All right? So again, what is the highest point that this reaches? 1. What is the lowest point? -1. Okay? Now, how long did it take for us to complete one cycle? We went through one circle of the unit circle, and so my angle went from 0 to how many pi?
2 pi.
To 2 pi, right? So please remember, if there is nothing else that you remember, please remember that one cycle is completed over 2 pi. So that's what guess what we call that? The length over which I complete one cycle, that is called the period of the function. Okay, so if you go up here, it tells you that the period of the sine function is 2 pi. The period of the cosine function is 2 pi. What that means is, in its default form, one cycle is going to be completed over a length of 2 pi. Okay? All right? It's always going to start 0 and then finish at 2 pi. Okay, so now look at what else I need you to see. For the sine, we hit 0, the maximum 0, minimum 0, right? So we're going back and forth between 0, max, 0, min, 0. Look at the cosine. We have max, 0, min, 0, max. Again, right? We're going from max to min to max, and we're hitting 0 on the way. In each of these, how many points did I highlight?
5.
5. Okay? These are the 5 critical points. when you graph, you have to show me the 5 critical points on the x-axis, and then it's just like boom, 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 boom with points, and we're done graphing. Huh? No, I'll show you how I want you to do them. Okay, so here we go. Now, remember how we said in the equation you had A, B, C, and D, and each one of them did something? Well, we're going to first start talking about the factor A. The factor A provides a vertical dilation. Basically, what that is a vertical stretch. Okay. So the highest point goes higher and the lowest point goes lower. Now, if for those of you that are musically inclined, okay, if you were playing an instrument, and if you were to, let's say, hit like a C, okay, and then you hit an F, what happens is both of those are waves. The C is a wave. The F is also a wave, but it kind of goes faster. All right. Now, if you play softly versus very loud, that's what we're talking about here. This is like volume. All right. So when there is a vertical stretch, it's again a C, but louder or softer. Okay. Now, if A is greater than 1, if the absolute value of A is greater than 1, this means there is a higher amplitude. If A is less than 1, there is a lower amplitude. Now, what is amplitude, you ask? How do we measure amplitude? I'll tell you how. You see this graph here of a sine or a cosine? If you split it vertically down the middle, the distance from the middle to the top is amplitude. The distance from the middle to the bottom is amplitude. It's the same. Okay, so you guys ready? We're going to graph our very, very first sine function. Here we go. All right, here, whenever I ask you to graph one of these, I'm going to give you a grid that looks like this. And then it's up to you to put on here the x-axis. Okay, so for this, first we're going to graph sine of x, just simple old sine. Now, what did we say about sine of x? It has a period of how many pi? 2 pi. So it starts at 0, so here at some point I put the 0. And then I have to go over 4 spaces. I have to put 4 tick marks. So I go 1, 2, 3, 4. You can skip spaces if you want, or you don't have to. But here I put 2 pi. Now, this is probably the most difficult part. This blue is straight up the middle between 0 and 2 pi. What's that point? Just pi. It's the middle from 0 to 2 pi, that's pi. Okay, this green is straight up between 0 and pi. How much is that? Pi over 2. Yeah, huh? And then this one here is between pi and 2 pi. How much is that? 3 pi over 2. Okay? Now, once we do that, believe it or not, this was the hardest part of graphing a sine function. This was the hardest part. Now, if I'm going to graph the sine function, the first thing I have to remember is the first point. Is it on the axis or is it above or below the axis? The first point is on the axis. Do you see that? So, I put my first point on the axis. Then I go up 1, 0, down 1, 0. So these were the 5 critical points in the colors. And then I go 0, maximum 0, minimum 0.
So that is
3 pi over 2. Once I do that, here's my graph. That's it. So that's f of x equal to sine x. Now, here I have g of x equal to 4 sine x. All right, I'm asked for the amplitude here. The amplitude is this value of a, so in this case, it's just 4. All right, now I want to graph that. It's still a sine function. So at 0, it still starts on the axis. Now that the amplitude is 4, instead of going up 1, I have to go up 1, 2, 3, 4. And then to 0, down 4, and then to 0. So again, you have 0 maximum, 0 minimum, 0. It oscillates, goes back and forth. Okay, and this is g of x. Okay, so do you see that this value of 4, the only difference it made is it made the highest point higher and the lowest point lower. Did it move the maximum left or right? No. Did it move the minimum? No. Did it move left and right where the zeros are? No. Okay? All right, let's do another one. Now I have sine of x and half x. Okay, so I'm going to draw my x-axis. And I put the values on here. Okay, this time, just because I can, when I start from 0, I'm going to skip boxes. So I'm going to go 1, 2, 3, 4, because I can do that. It's preference. All right. The last one is 2 pi. Always goes from 0 to 2 pi. And then I put in, like, pi over pi over 2, 3 pi over 2. All right, so let's graph sine of x. Start at 0, maximum, 0, minimum, 0. Okay. What's the amplitude of g of x?
1/2.
1/2. That means I start at 0, and then the maximum is where? In the middle, 1/2. 0, in the middle, 0. You see that? That's a little itty-bitty graph. So now I just went softer. So it's the same note, just softer. Okay. So do you see how once you draw the x-axis and you label the 5 points, the rest is like the easy part? It's ironic. Okay, let's do this next one. Cosine. Okay, it's cosine, but we start the same way. Sine and cosine are very good buddies. They have a lot of similarities. I'm going to start at 0, 1, 2, 3, 4, 2 pi. Pi over 2, 3 pi over 2. Okay? Okay. Now, cosine. When the angle is 0, how much is cosine of 0? Cosine of 0 is 1, so when the angle is 0, it starts at the maximum. That's the difference. So cosine starts up here, and then it's got to oscillate around the x-axis. So it's got to go back to 0, back to -1, 0, 1. Okay. This is the, okay, and then we label this. This is the, from now on, we're just going to draw the, like, straight up the actual graph. And then for g of x, what's the amplitude? 2. So I start at the maximum again because it's cosine, but instead of starting at 1, I start at 2. So maximum 0, minimum 0, maximum. Oh, shoot. Okay. Okay. That is cosine of x, cosine of 2x. Isn't that pretty?
Mm-hmm.
It's like so satisfying again. Okay. So let's go to what it looks like if there is a reflection around the horizontal axis, right? Reflection around the horizontal axis means it's flipped vertically. Oh, we don't say flipped. We say there is a reflection around the x-axis. Okay? All right. When that constant a in front is negative, we say the graph is reflected around the x-axis. Okay? So now, I think I'll draw cosine for this one as well. Okay, so we need to draw a cosine. Again, we're going to go 0, 1, 2, 3, 4 to 2 pi, pi over 2, 3 pi over 2. So on tests, quizzes, homework, there's points awarded on tests and quizzes for the 5 points on the x-axis. So if you don't have those, you wouldn't get full credit. Okay, now cosine would have looked like this, right? We're going to do that quickly. Okay, now here's the biggie. Amplitude. Remember how we said that amplitude was the distance from the center up? Can distance be negative?
Mm-hmm.
No. So what's amplitude here? Just 2, not negative 2. Okay? Now, however, we can't ignore the negative. That negative is a reflection, right? So if this was 2 cosine, we would have started 2 above the x-axis. But since it's negative 2, we start 2 below the x-axis. So we start here. Now, we always oscillate around the x-axis. So from that point in red, where am I going to go? To 0. So it's minimum 0, maximum 0, minimum. Okay? That's g of x. Yes. So 2 things happened. Not only did it flip, or it was reflected around the x-axis, but also the amplitude got bigger. So instead of going up and down 1 unit, it went up and down 2 units. Okay, next, I want you to do the last one on your own. What you're going to do is you're going to draw the x-axis. You're going to put in the points and then put in sine of x and negative half sine of x. I'll pause this for a sec. So if you just graph that, the negative half. So this is how you're going to do it on the homework. You're just going to graph this one. What's the amplitude for that? 1/2. But since there is a negative, it goes down. And so it's like this, cute little wave like that. Okay? Now, the worksheet has 10 graphs on there that you have to graph, and I've given you the grid. However, it's a deal breaker that this x-axis, you have to do it with a ruler. All right? It's not, or a straight edge or whatever. And it's not that difficult. If you want, just take a straight edge, do 10 of the lines from the beginning and then go and graph them. I will be looking for